Good morning, good afternoon, or good evening, depending on where you're tuning in from today. And thank you for joining us for today's masterclass in the new Dot3D 4.0, in particular for Intel RealSense and the new LiDAR camera L515 and depth camera D455. Today we'll be working through a brief presentation introducing some of the new features in Dot3D and the new benefits of each of these cameras. We encourage you to submit any questions via the GoToWebinar panel at any time throughout the presentation, and we will address them as best as we can and as time allows at the end of the session today. And we will also gladly follow up via email to any questions that are submitted. Please keep in mind that this is a truly live web demonstration, bear with us. There might be a little bit of a slower frame rate during the live scanning that we're doing today on an Android platform. And if anything does go wrong, be a little patient. It should go smoothly, but it is live. So first to introduce myself, my name is Chris Ahern. I'm Marketing, Sales, and Product Manager here at DotProduct. I'll be leading the presentation today, walking us through both the slides and the live scanning portion. And I'm honored to have our CTO, Rafael Spring, on the line with us today as well, who will also be here for the questions at the end.
Hello, everyone.
Thanks for joining, Rafael. So to quickly introduce what we do for anybody who is brand new to us on the line today, I know there may be some new users or new interest joining for this session. So we are a small growing company focused exclusively on handheld 3D scanning, and we've delivered a lot of different products in the handheld scanning realm over the past 7 years. From the beginning, we've focused exclusively on handheld scanning and delivering a solution that achieves what you see listed here. So we have a lot of different growing options now, as you'll see today, but it's all targeting the same core goal of producing a solution that is truly mobile, so you have full freedom of motion to walk around the area of interest that you're capturing, simple to use with a user-friendly interface, so field workers across industries can get up and running with the technology fairly easily. Completely handheld, so not only no tripod necessary, but no laptop required, no long cumbersome cables or anything along those lines. Fully self-contained solutions, even if they are a component of a couple different parts, they all sit nicely in your hand. Also inexpensive, so our packages and these varying different options that you'll see today range from as low as $1,000 all-in starting cost to, for our high-end DPI 10 kit, still only about $6,000 all in, and that's hardware, perpetual software license, everything you need. It's also very important to focus on providing accurate, reliable data, as you'll see today. And all of our data sets allow for referencing known measurements, and we're going to be measuring directly from the scans that we take today. And of course, real time. So that's the core of what you're going to be seeing today, as we actually do scan live throughout the session. I'll take most of the questions at the end, although there's a quick question about what type of accuracy we're talking about. This varies depending on the different cameras that we utilize even today, but the attainable accuracies that we're generally talking about here are 2 to 5 millimeter measurement accuracies, close range single room measurements, and with references for larger area scans. So this presentation to introduce us before we switch over to the live broadcast of the scanning device is going to cover the 4 components of a Dot3D scanning kit. Of course, the prize component here that we're going to be focused on today is the Dot3D software itself, and in particular the new 4.0 version, and highlight all that brings to the table. But with 4.0, with our past releases, and with any kit, there are some other components that will be required to create your own handheld 3D scanner. The first is the tablet or phone that you're operating on, and we're continuing to keep up with new, more powerful tablets and phones with our latest options. Next is the depth sensing camera that you choose to utilize. So we now support the full line of Intel RealSense depth cameras, our line of DPI 10 PrimeSense depth cameras, totaling 6 or 7 different options that you have, which we'll cover today. So you choose your tablet, your phone, your depth camera, and you get set up with the Dot3D software, and you're ready to go. The 4th component here, which we won't necessarily focus on as much today, are optional accessories. So you can add a light kit for capture in the dark, add an extension kit for hard to reach areas, etc. So we'll take each of those one by one. The supported hardware is growing in terms of options that you have at your disposal. So we want to mention that we have some excellent rugged tablet options. Some of these even build RealSense cameras into the back of the rugged device, which is a very powerful solution, or can attach as an add-on, similar to what we're doing today. So rugged solutions that you may or may not already have on your job site from companies like DT Research, Mobile Demand, Zebra, Trimble, and more on Windows and Android platforms are fully compatible with our software and our supported depth cameras. Typically, we also deploy on the Surface Go or Surface Go 2 very frequently. This is a tablet that's compatible with our DPI 10 line as well, or your standard Surface Pro tablets from the Surface Pro 4 to the very latest models are also fully compatible with Dot3D and with all of these different depth cameras we're using. We also support a full line of Android tablets on the DPI 10 setup. We typically utilize the Samsung Galaxy Tab S6. And as you can imagine, there's a lot of other options out there, many of which we have tested, many we haven't yet, but a wide variety of options on Android and Windows. In addition to tablets, we are also now supporting phones. So this is a very powerful pairing of both our software and these smaller, affordable, very convenient cameras from Intel. So this phone you see here is actually what we will be scanning from today. This is the Samsung Galaxy Note 20 Ultra, and it has an Intel RealSense D4.5 depth camera, in this case, attached to the back of it. At the bottom of the screen here, you'll see some of the phones that we've tested successfully so far. Although Android is an incredibly huge platform in terms of options. So we haven't tested them all, but we're continuing to test more and more to determine which run best with our software. But the Galaxy line from Samsung, the Pixel line from Google have been some good options so far. So to touch on that a little bit more, on this screen, we highlight the general specifications required for use of Dot3D on these two different platforms. As mentioned, Android can be a little bit more finicky because there's just so many different models out there. Windows is generally a little bit more consistent, but we found some excellent results on both platforms. With Windows or Android, as you see in bold here, the number one thing to check first, and what we oftentimes find is catching people early on, is to make sure that you have a USB 3.0 or higher port, or USB 3.1 typically. Even if you're scanning from your laptop for some tests, for example, sometimes certain ports are USB 3.0, while others are still USB 2.0. Sometimes on Android, even though it's the new USB-C port, that doesn't necessarily mean it's 3.0. So that's definitely something you want to verify and test as you get started with Dot3D. The rest of this is pretty straightforward, reasonably recent machine with decent specs, and it needs to be an a Windows 10 or an Android 7 or up. Next, we're going to touch base on all of the different supported sensors that we have. So our goal here is to be the tool that allows you to plug and play the best camera for each different environment that you want to capture 3D data from. So until Dot3D 4.0, what you see on the screen is what we have been supporting for quite a while now. The DPI 10 and DPI 10 SR kits include custom calibrated PrimeSense Carmine cameras, which still offer an excellent complete solution for versatile indoor scanning. The Intel RealSense D400 series has already provided us with the D415, the D435, and the D435i, which are all also fully supported in Dot3D. Until Dot3D 4.0, our focus has been on the 415, as this was the best of those three options for 3D scanning purposes. And the biggest benefit that this added on top of what we provide with our PrimeSense solutions is the ability to scan outdoors in the sun. We're continuing down that trajectory with the D455, as you'll see shortly. So now we have a couple slides to focus on the meat of today's presentation, which are the new cameras and what benefits they bring to the table. So this year we've seen the release of the Intel RealSense LiDAR camera L515. This is the first LiDAR camera that we've released official support for, and it's a great option for a lot of different situations. In particular, the benefits of the L515 include the longest range of any camera we've supported so far. So in a fully indoor environment, you can see up to 6 meters at any point in time with the L515. For comparison's sake, none of our other cameras are seeing past 3.5 to 4 meters at any point in time. It's also very inherently accurate given the nature of the LiDAR technology. and comparable to the accuracy you'd get out of a DPI-10, for example, with our calibration in ideal conditions. It's also very small, very light, and very affordable. So easy to pop on the back of a phone, the back of a tablet, attached to your DPI-10, and starts at only $349 from Intel directly. Or there's an option to purchase through us with a magnetic mounting kit and approved USB C-to-C cable for still only $495. A few drawbacks we should mention and touch on throughout the day today for both cameras. It does not work in direct sunlight. So the D400 series is still what we're going to recommend if you need to go outdoors and scan in bright sunlight. It's also worth noting that the L515 is particularly sensitive to ambient lighting. So whereas our DPI solutions are also indoor only, they're not really bothered by window light. That's not really an issue. It's just you can't scan outside in direct sunlight. With the L515, you will actually run into issues with window light as well. So you want to keep that in mind when deciding on which camera is going to be the best fit. Similarly, not necessarily the best option if you have a lot of black, gray, or shiny surfaces. So both ambient light or these dark surfaces aren't necessarily going to prevent it from working entirely, but they will significantly reduce the range. So you're going to have to get in a lot closer if you're dealing with some of these more challenging type surfaces. Yep, go ahead.
Oh, just to chime in here a little bit on the ambient lighting for the different cameras. The situation is there are certain circumstances for which a particular camera works really fantastically well and the other camera just doesn't work much at all. For example, if you're using an Intel D400 series outdoors, works fantastically well as long as you has texture. Most of the time you do have texture because all the natural built environment from the outside and or is it nature or is it asphalt? There's always texture there that you can use or the camera can use to calculate the depth. So that works great. If you take a DPI with the PrimeSense outdoors, that most of the time won't work. If it does work, then it's going to be either at sunrise or at sunset or at night, because the sunlight that is shining onto the scene is washing out the IR pattern that the PrimeSense camera depends on for the depth calculation. The Intel D400 series cameras are not so dependent on the IR. They do have an emitter. That emitter helps indoors when there is no texture, for example, on white walls, so they can still calculate a depth value. But outdoors where you have texture, the emitter of the 400 series gets washed out as well, but they don't really care as much because they can't calculate the depth from the texture. Sure. The L515 is a different, entirely different beast. Whereas the D400 and also the PrimeSense cameras, they're assisted stereo and structured light respectively. The L515 is a true LiDAR camera. And so they have a little mirror inside, a so-called MEMS mirror, that is deflecting a laser beam really quickly across the field of view and basically scans an image. Very advanced technology. It has a lot of advantages in terms of range, in terms of accuracy. And as Chris already said, indoors you can get up to 6 meters. But it also has drawbacks, and they're very particular. If you're scanning indoors and there is ambient light coming from outside, meaning ambient sunlight, then your range will go down and your accuracy also somewhat. When there's very bright ambient light, your range will go down even more. Interestingly, if you're getting close, though, you should still be able to acquire data. Like if you're getting close to like a meter, even if you scan something that is completely exposed to sunlight, like direct sunlight, you can still scan it if you're close. On the other hand, though, if you're scanning something that is let's say 3 meters or more, and there's a lot of ambient sunlight around, you won't get a lot of signal here. So whereas in those conditions, for example, the PrimeSense and the D400 series would work without a problem. So
Sure.
yeah, Chris, that was just my technical take on things.
No, perfect. Thanks, Rafael.
Sure.
Much appreciated. And just highlighting, as I started to say here, that there's a reason why we support so many cameras. It's not just for the sake of supporting so many cameras, it's because each one is a little bit better in different situations. So that brings us to the next one, which is the even newer Intel RealSense depth camera D455. And this has its own set of benefits and drawbacks we'll touch on now. So it is a significant improvement in almost every category over the previous D400 series. So it has a longer range and shorter range. So it's an improvement on both ends of the spectrum over the D415, the D435, and even the DPI-10 with a 1 to 14 foot range. It also has a very wide field of view, which can be really helpful in terms of tracking stability. It can also be helpful in terms of capturing a large scene rather quickly, as it can see so much at any point in time. It also has the prime benefit when compared to the others of being daylight capable. So similar to the 415, which was our previous recommendation for daylight scanning, given the nature of this depth camera, it will work even in a bright sunny situation. So it opens up a lot of doors there. And similar to the L515, it is very affordable. So starting at, actually I should say only $239, I believe, from Intel, or $595 from us, as we do offer a custom calibrated version of this camera. So similar to what we're doing with the 415 or with the DPI-10, we're doing a sensor-specific level of calibration for each of these cameras to improve the accuracy attainable with each one. So that's an option, but calibrated or uncalibrated, both are supported. And then to the drawbacks. So it is inherently a little bit less accurate than the other options that we're touching on. So you get the benefits of outdoor scanning, wide field of view, etc. Great for indoor and outdoor applications, but it's not going to be as accurate. So you will see a little bit coarser resulting data. We'll want to try and reference some known measurements more frequently if possible. It is the largest and heaviest of the RealSense cameras. However, that's not saying much. They're all small, but it is a larger and heavier model. And as you will likely see today, if we go outside and capture some data outdoors, versus the 415, that would be the one drawback here, is that we've recognized that in direct bright sunlight, there can be a pink or purple tint to the data sometimes. It's not hindering the capture, but it's just a tint that you will see in the resulting data. Not always, but sometimes in direct sunlight.
Also, just very quick, another key benefit of the D455 is due to the wide field of view. You're going to capture more area of the scene more quickly than with any other sensor. So, for example, the 415 only has about a 65-degree field of view horizontally. And so that makes a very substantial difference when you're going around scanning something. You'll notice that with the 455, you'll just be done quicker than with the 415 because you're just able to capture more data in a period of time.
So we'll pause on this screen for just a minute. This is, if you want to take a screenshot or take some notes, a couple links that elaborate even more on the comparisons that we just made, and also include these other cameras directly in the comparisons. So Intel has a lot of details on the particular specs of each camera lined out and compared at the web page you see here. Our knowledge base, which is available directly from DotProduct3D.com, also lists out each camera we support along with some of the different benefits. And then we recently released a blog that kind of takes each category of relevance and ranks them, in our opinion, as which performs best. So outdoor scanning and sunlight would be one, indoor scanning, price point, form factor, they're all taken into account. So now we get to what we're using today. We have obviously a lot of options at our hands and a lot of different tablets at our disposal. But in this case, we decided to show a phone. It's a really powerful new capability that you can be doing accurate color point cloud 3D scanning from your phone. So that's what we're going to be focusing on today. We will be using both the L515 and the D455 to demonstrate and highlight some of the different pluses and minuses that were just touched base on in the presentation. In this case, we're utilizing a convenient kit called the Iographer. And this is basically a photography kit that we've repurposed for 3D scanning purposes. And your phone will slide into the back. You have the option of adding a light on top if you're going to be scanning in the dark. And we've easily magnetized actually both of our cameras to the back of the kit. I'll be using the, as mentioned earlier, Samsung Galaxy Note 20 Ultra. It's important to note that don't want to be deceived by this image. We're not using both cameras simultaneously at any point in time, but I can just swap the cable out whenever I want to switch between the two. And lastly, before we finish this presentation, we of course need to cover some slides on the core product here, which is our Dot3D 4.0 software and what's new with that. So the first bullet here we've already covered. It brings the first official support for the new LiDAR camera L515 and depth camera D455. So we've already covered that fully. It also brings multiple measurement capabilities, annotation improvements, exportable measurements, annotations, and HD photographs, improved Re-Localization functionality, which I'll show live, a new autosave procedure, and more. So you'll see all of this live as well. So we'll move relatively quickly through here, but in past versions of Dot3D, it was only one measurement at a time. You could move it around to get multiple distances, but you couldn't actually save them separately into your scan. So you can now take as many measurements as you like and save them directly into your DotProduct DP file. We also added what's called scan time annotation with the release of 4.0. So this is really useful for particular documentation or inspection needs where you actually want to, as you're scanning, if you notice something that needs repair, you notice a piece of evidence that needs to be documented, you can use that crosshair on your scan screen to flag it while you're scanning. And that adds a 3D annotation during capture that will then prompt you to cycle through and fill in the details of each annotation after the fact. You can still always add annotations separately afterwards, but in certain situations, it's really helpful to be able to do it on the fly. We've also continued to expand our foreign language support. So Dot3D now fully supports English, German, French, Spanish, Italian, Mandarin, and Japanese. And we're actually now already on to Dot3D 4.0.1, which that second update, it included a couple hot fixes and some improvements to these translations. The relocalization improvements. As you'll see during the live scanning, a really important piece of our technology is maintaining tracking, cutting it off if it doesn't trust the data that's being captured, and regaining it easily to continue from where you left off. So now if you do lose tracking from motion, being too far away, too close, hard to reach area, if you trip, there's a lot of reasons that can happen. You'll see this screen, which prompts you to either just naturally move back, which oftentimes will work, but if it doesn't, you select pick relocalization area on the bottom right, and then similar to our append or align procedure, you select a frame that you're comfortable repositioning on, and then you continue from that point very easily. We've also improved and streamlined our autosave and calibration procedure. So this is a simple change that kind of helps logistically with all of our users. Anybody who's been with us for a long time might recognize this setup from our past application, Fi3D, and we're bringing it back because it makes a lot of sense and makes things really easy to have an automatic backup at all times. So as soon as you finish your scan, it's always auto-saved, which we've always done that, but now we have a separate folder that's automatically created on your device, and every autosave goes directly into that autosave folder with a timestamp. So this is a great backup that you can always revert back to at any point in time. Similarly, we are now automatically creating a calibration folder on your device, and this is just to streamline the process of loading a calibration file in if you have it. So this is relevant to the D455, the D415, and the DPI-10. The L515 is so inherently accurate as a LiDAR camera that we do not offer or require any additional calibration for that camera. And to take advantage of that calibration folder, you just put your calibration files in there and select scan calibration folder from Dot3D. The additional improvements include an overhaul of the user interface, so cleaning everything up and improving the user experience. We've also added some latitude and longitude referencing capabilities. If you want to elaborate on that a little bit, Rafael.
Yeah, absolutely. So this was a request that was brought to us by a lot of users that want to reference their data to other data that they've captured with other systems, let's say with a drone or with a laser scanner, or they have targets up in the scene or other sort of landmarks that they've surveyed in and where they have latitude and longitude coordinates for. And so what we do in the software is we're able to reference those coordinates, right? So we do that in two ways. So the first way how you can do that is to put in an annotation on the spot and give it a latitude and longitude coordinate. And the second way how we can do that is through our coordinates feature, right? So in Dot3D you click on edit coordinates, and that gives you the ability to set a new coordinate system for the scene, right? And we've added a new option that allows you to specify a lat long for a particular point that you pick, and then specify the orientation of the coordinate system through classical methods that we already have in Dot3D, like you can select a floor plane or a wall, and then you would have one of the axes be perpendicular to that. The whole thing gets a bit tricky when it comes to how does it export, because when we export the scene, well, first of all, you can always export the annotations with the lat long, with the lat long that you provided, and so you can do that as a CSV or as a JSON file. But if you want to export the point cloud, that always exports into an XYZ format, right? So you always have a Cartesian coordinate system, 3D coordinate system with XYZ coordinates, regardless of which format you use, whether that is PLY, whether that is the DP file format, whether that is PTS, PTX, RCS, whatever. It's always going to be XYZ coordinates for each point. And since lat long and XYZ are not naturally compatible, right? So one is a Cartesian 3D coordinate system, the other is a geo-coordinate system with angles. There needs to be some transfer between the two, right? So at some point there's got to be a transformation between the scene coordinates and that are in local coordinates, then taken into account the lat long that you provided, and then going into the destination coordinate system where everything is again referenced in XYZ. And this last missing link is where local geo-coordinate systems come in. I have to admit I'm not a geospatial professional, so a lot of people, maybe also a lot of people on the webinar are much more professional in that regard than I am. But what we do today is that we let the user convert it into state plane coordinates, which are used throughout the entire US. That was basically what a lot of our customers told us that they needed state plane. And state plane actually provides that missing link from a lat long referenced coordinate system to an XYZ, right? So the whole transformation is like you have the XYZs and local scene coordinates, you have the lat long that you provide. Those two together, they transform into the new XYZ-based Cartesian coordinate system in state plane coordinates. Now, state plane is only one target coordinate system that that is available, and it obviously only works for the US. You cannot use it in Europe or Asia or South America. And so what we're going to do in one of the next versions, maybe 4.1 or maybe 4.2, is add a lot of new options here, right? So not just state plane, but also UTM coordinates, which are worldwide. And then maybe some more, maybe we'll hear more from our customers what they would like to see here. So it starts out with state plane. You can do the annotations, and you can do coordinate system, and then down the road we're going to add more of those local geo coordinate systems.
Perfect. Thanks a lot, Rafael. And just to touch on the last bullet here, which I'll show you shortly, we have an April tag display options. This is a convenient addition to the software that allows you to see the unique ID of each April tag in your scene. For those that are new to us, these are some optional targets that you can put in your scene just for automatic accuracy improvement anytime you loop over them, or if you want to reference known measurements or known coordinates, they're extremely useful. And we have a few of those in our scene today. And we've already surpassed our midway point of the webinar, so I think it's about time we stop talking about this and start showing it live. So bear with me momentarily as I switch my video and audio over to the phone and transition into our scanning space. Okay, so you should be able to hear me now from my Bluetooth headset connected to my phone, and also see my Android screen. So it seems that things are going a little slow over the live web broadcast here. So hopefully it catches, but just be aware as we do the scanning, the pace of motion throughout my scene, for example, is much more natural than it'll appear on your end. It's really a natural standard walk through your scene type situation. So I've opened up Dot3D. I've plugged in my L515 to start. And you'll notice that because we're now supporting so many different cameras, as you plug in these different options, you will need to go to this screen, your home gallery view, and just press confirm. Once you've done that, you can start scanning with the plugged in camera. Before we start the live scanning, I'm just going to quickly touch base on the settings that have changed with 4.0. So if you go to your settings tab and select sensors/cameras, you can now access each camera that's plugged in. This even supports if you have multiple cameras plugged in at the same time. While you can't be scanning from both at the same time, we had to take this into account. For example, for our customers with DT research tablets that have embedded Intel RealSense D415 cameras, we want you to be able to also plug in an L515, for example. To check on your camera settings, you press the camera on the left. And one option I want to highlight here is the use LiDAR IR as color stream. This is a brand new capability with the nature of the LiDAR technology, where you can actually be scanned in pitch black with the L515 without a light at all. So if you want to stick this down a drainage ditch or a manhole, and you don't necessarily need to have a light attached to the end, you can scan even in the dark with the L515, and you want to check that button. And that'll produce grayscale data, but it works excellently. Can even recognize April tags using that option. Additionally, we mentioned the new annotation capabilities earlier. So in addition to scan time annotations, we also have annotation classes. So this allows you to set up custom classes specific to your need. So if I go to photos and annotations, and I have this new option here to set up annotation classes. So the default classes that we have are just generic point annotation, plane annotation, cylinder annotation, or photo annotation. If I want to create a new one, I just press the copy button. Can call it whatever I want. We'll call it webinar annotation. And then you can press the pencil icon to edit it. So this allows you to create custom fields specific to your need. So if URL isn't relevant to this type of annotation, you can X that out. If lat long is not relevant, you can X that out. But if you want another text field, so call this sample option, you can customize all of this specific to your application. So for inspection needs, this is really useful. It basically creates a form that that you need to fill out when you're capturing a 3D scan or when you're annotating to one. So that, when we go to annotate later, will show up as one of our options, just like the rest of these here. All right, so with that, I'm going to move to the room next door, which some of you may recognize if you've been on some of our web demos before. It's the electrical maintenance room here at the DotProduct facility.
So now we're ready to start our scan. I'm re-recording this section of the webinar for your convenience due to the Wi-Fi glitches and slight lags that we experienced while capturing earlier today. Upon review, most of the content did come through live, which I was glad to see, but for your convenience, we're re-recording this to make it a little bit more succinct and give you a clean impression of the frame rate that we use while capturing our scan. So to start my scan, I press New Scan on the left, and it connects to my Intel RealSense L515 LiDAR camera. To start my scan, you want to press the button on the right, and you'll immediately begin capturing a color 3D point cloud dataset of everything that you point your device at. You'll notice that there are a few April tags in my scene that are turning orange automatically recognized. I will utilize these as my start and finish point while scanning. You'll notice the nice long range of the L515, one of the major benefits of this camera in particular. Makes it a lot easier to capture the ceiling, the rafters, anything far away. One of the benefits of this camera is not just its accuracy in general, but in particular its accuracy at range. While some of the other cameras can compete in terms of accuracy, they do require you to get a little closer in order to get those levels of accuracy. Obviously, the L515 is still more accurate when it's a little bit closer, but it does very well even from further distances, as you can see here. So as discussed earlier, the range of this camera in an indoor environment is up to 6 meters. So I'm just going to quickly move around my entire room, turning it green or at least yellow. Whatever is most important to you, you want to spend a little bit more time on or maybe get a little bit closer to, and turn nice and green. And it's a simple point and shoot technology for those of you that are new to our software. It's as simple as what you see here. Make sure I fill in this whole area of the floor, and I can take advantage of the 3 different buttons that I have on my screen while scanning. Bottom left is my plane picking function that allows me to flag my floor as being a flat level surface. And in that manner, when I'm over here at the same floor and I flag it again, if for whatever reason there wasn't a clean overlap between those 2 sections of floor and there might be some slight tilt between different parts of the floor and the resulting data, by flagging it, you make sure that there isn't. It'll automatically apply during optimization and make sure that that floor is level throughout the different areas where you captured it. The other buttons that we have access to here include the HD photo capture feature. So if I want to get a high resolution image of this particular electrical panel, I press and hold and release to capture the HD photo from my phone's high resolution 2D camera that is exposed in this iographer kit that I'm using today. Lastly, we have the crosshair icon, which is specifically new to Dot3D 4.0 that allows me to make the scan time annotations that we touched on earlier. So if I want to annotate to this switch here, I get in close, press and hold, it gives me a preview screen and a crosshair, and then release when I'm ready to annotate. And that adds a 3D annotation point to that particular point of my scan, and I can fill in the details on that annotation after optimization. So we've pretty much captured this whole room, nice, good, clean, green scan, and we're going to finish back at the same April tags that we started at. So I press the same button I pressed to start to finish my scan. This file is automatically auto-saving to that new Autosave folder as discussed earlier, so you'll always have that backup to revert back to if necessary. So we can take a look at our quick preview. This is not the final product. It is important to note that this is the unoptimized data. So Any blurriness, imperfect overlap is all completely normal, as this is just a preview. It's your chance to make sure you at least got everything you wanted. It's not necessarily representative of the final quality. You can also build back into this data, which is what we're going to do today, even with a different camera. So my first step is going to be to save the file. You'll see at the bottom of your screen at all times, it'll tell you where your file is saved to. So that's the automatic save in our Dot3D data folder. But I'm going to resave it for my own convenience. And I'll save it as Dot3D 4 webinar. Done. Save scene. So in the compressed .dp point cloud format, that saves very quickly directly to my hard drive. And now I'm going to connect my D455. I'm going to open the door and I'm going to go scan outdoors and link those two scans together here in Dot3D. So in order to activate my D455, I've got to back out of this scan to my gallery view and press confirm. To verify your calibration file is loaded, if you have a calibration file for your D455 provided to all DotProduct ordered D455 kits, you want to go to Settings, Sensor/Cameras, tap on your Intel RealSense D455, and then tap on the Calibration tab, where you can see that my calibration file specific to this camera has been loaded in automatically. If this is your first time using Dot3D with that camera, or you otherwise need to load a new calibration file or make sure it's been loaded, you just press the Scan Calibration folder and it'll automatically load in any calibration files that are in that folder, Dot3D/calibrations. You don't have to do this every time by any means. You can put 5 different calibration files in that folder one time, and then every time you plug in a different camera, Dot3D will automatically recognize and apply the proper calibration. So now we're going to open up the door, load our scan back up from earlier so we can use the append capability. So it's Dot3D 4 webinar.dp. Then press the scan button, append to this scan. So this is allowing me to select a frame to reposition myself in and continue from where I left off. So I want to select a frame relatively near the area that I want to add, which is out this door, that I'm comfortable repositioning in. So I'll choose frame 11. Now I'm connected to my D455 and I'm going to line that frame up with reality. The April tags are not required for this feature, but can sometimes be helpful and always are good to start and return to for any scan, including this append. So now the door has been opened and I'm able to move with my outdoor capable D455 outside. In our practice scan yesterday, we were capturing a green scan outside here, but given New England, things changed, and we are capturing a very white scene with the D455 camera. We'll get some data on each of these bushes, some of the wall, with any camera that you use with Dot3D, a major benefit of the real-time feedback is to see if an area is giving you trouble. So this metal ridged panel is a little bit of a challenging area. So you just want to be a little bit more patient with it, get it from different angles and distances until it fills in a little bit better for you. If you lose tracking like we just did, it'll typically find itself right away. If I hadn't regained tracking so easily there, I could always use that pick Re-Localization area option that we discussed earlier, which is new to Dot3D 4.0. So it's kind of a nice option to have if it doesn't find itself right away. Our plane picking function from earlier can also be used on walls. So if I flag that wall as level, I can do it again on the other side of the stairs. So I'll just back up to where I just was, and it usually finds itself extremely easily. So I'll get some good green data on all the equipment here. And you'll notice these bricks capture particularly well, even in this bright, white, sunny environment. So if it's a shiny surface like this, just get in a little closer. And unless it's a truly mirrored surface, you can always fill it in, even outdoor in the sun, if you're using the D455. So with that, I'm going to go ahead and move back into the room. And as you should with every scan you take, finish back at the same April tags that you started at. So I'll finish back at these two tags. Oh, just moved a little too quickly at the end there. Finish back at these two tags, press the button on the right, and finish my scan. So now this is again auto-saving to that same autosave folder automatically, but as a separate file that'll indicate that it was annotated to. So you have your original autosave, and now you have a second autosave that is actually a single file with both our L515 scan and our D455 scan seamlessly added to each other. If you want to use this append feature but you've already maxed out your single scene size, we also have an option called align. So append, if you noticed earlier, I did before optimizing. Align you can do after optimizing. So that captures distinct separate scans in the same coordinate system as opposed to building directly back into the same file like we did today. So here is again is our unoptimized preview. So we'll just take a look and make sure we got everything we need. And let's go ahead and optimize. We want to see the good stuff, the final result. So I'll press optimize. It'll automatically check the boxes to use those plane parallelism constraints that I flagged while scanning, to use April tags for loop closure since it recognizes that there's April tags in my scene, and to level the colors throughout our scan automatically. This optimization step can take anywhere from 20 seconds to even up to 20 minutes currently with some of our much larger scan capabilities. This optimization here today should take no more than 3 or 4 minutes at most. So we're going to go ahead and let that crunch. It's important to note that everything that happens from this point forward, you can envision happening here on the phone or tablet like it is right now, or you can envision it happening on your laptop or desktop PC. We have what's called a Dot3D edit license available for as low as $10 a month. And what that does is it gives you access to all of the capabilities of Dot3D Pro except for scan. So it allows you to offload some of the post-processing steps, which can be very convenient, especially if you're doing lots of scans in a single day. If you're doing a very large area scan, it's nice to be able to manage that data off of your phone or tablet. On the other side of it, it's also very nice to have the option of being able to optimize, see your final result in the field on your phone or tablet too. So you have either option at your disposal. You can definitely do everything on your scan device if you need to.
As that optimizes, which shouldn't take too long at all, I will also start to pull up some of our questions we've had so far. So we had a question about if any of the options will work in total darkness. I think I covered that probably later on in the presentation, but the answer is yes. The L515 will work in total darkness. Next question is, if the L515 is a true LiDAR camera, why does the sunlight wash out the signal when a typical terrestrial LiDAR scanner has no problem? If you want to chime in on that, Rafael, go ahead if you'd like.
Absolutely. So the LiDARs that you see from the typical vendors like Velodyne and Ouster and RoboSense, those are typically automotive grade high power LiDARs. They send out, they have a much larger build. They are using more powerful lasers. They're consuming a lot more power. And so they can simply overpower the sunlight. It's the same effect as if you use the L515 and get really close to things. It does overpower the sunlight, and you can scan even though it's directly lit by sunlight. It's just that those more powerful automotive grade sensors, they have just more firepower. to combat the sunlight. That's basically the only reason.
Thank you.
So now the optimization is finished and we have more or less our final result to further edit and move forward with. So I'm going to zoom out and take a look at the data that was captured. So we've got a nice, clean, crisp L515 data set of this entire electrical maintenance room here, as well as a D4.5 scan of the exterior, capturing the details of the stairs, the brick wall, the HVAC equipment over here, and going into the scene here. With that append capability, I was even able to capture the door, maintain the door closed in order to prevent ambient light from my L515 scan, then append from a different corner of the room and move right through to capture my outdoor scan. So before we finish up the webinar here today, I want to show you what you can do with this data right away in Dot3D, in particular highlighting some of the new features that are available in the 4.0 update. So typically the first thing I do with every scan is manage my coordinate system. So this is to make sure my measurements have an accurate reference point to get the height, for example, of two different points in my scene. It's also a very good best practice for moving forward with the data into third-party applications. I want to make sure that they come in on a level plane with an origin point that makes sense. So if I go to Edit, Coordinates, that will give me the opportunity to set a coordinate system of particular relevance to my scan. By default, in this case, the software did a very intelligent job of taking a guess as to where you might want your coordinate system to be. It has already set my XYZ in the corner of the room by recognizing those planes. But let's say I wanted it to be in the other corner. Or for example, I wanted to set it to a latitude, longitude, or a specific known coordinate from another scan or from a CAD model. You can do all of that using the set coordinates function. In this case, we will just pick an origin point, press and hold, and release. Now you also want to set your primary axis straight up out of the floor, so you select the primary button, press and hold. Looks like I grabbed the ceiling instead of the floor by accident, so I will try that one more time. There we go. Now my Z-axis is coming straight out of that floor. Now if I press the secondary button and hold on the wall, now my X-axis is coming straight out of the wall. So now every single point in my cloud is referenced to that corner of the room. I press confirm, confirm. Before we move forward with some of the other new features, it's also good practice to crop your data set. So for example, we've got some stray points coming through the window here. I also want to crop my ceiling off just for convenience so we can see into our room a little bit more easily. So I will do edit, crop, and then I like to do view orthographic, view vantage point side. Now I'm looking at my scan straight on from the side with that orthographic viewpoint. So I can chop off a whole level of my scene like so, and it's a multi-crop capability, so if I want to also crop out some of this stray data through the window or any stray data underneath the scan, it's very easy to do so. Similarly, if I want to crop out the points that were captured through the chain link fence, I can do so by selecting. And whenever you are happy with what you've selected, all you have to do is press crop in the bottom right. Oh, it looks like there's some more stray points over here. I'll grab those too, and then press crop. So you'll notice that there is some pink in this outdoor scan. That is a known limitation of the D4.5. Not always, but sometimes in a sunny situation, especially with the white snow, you will see a pink tint to your data. It doesn't affect the accuracy or the quality of your scan, but it does affect the color. So as mentioned in the presentation earlier, if your goal is to have the most daylight capable camera that produces the most accurate colors, but maybe doesn't have the range or accuracy, you maybe will just go with a D415. So that's the one area where the D415 is still superior, but the D455 excels in all other categories. So let's show some of these new features that we have in Dot3D 4.0. So first we have the scan time annotation capability, that annotation that I captured earlier. You'll notice that my annotate button up top already has a 1 next to it. That's indicating that I captured an annotation while scanning. You have a constant count of how many annotations you've made. So if I press that button, this is my view where I can add annotations on a regular basis. But in this case, I want to complete unfinished. So I press the button on the on the left to complete unfinished. And it'll automatically bring up this high resolution image that's automatically captured whenever you take a scan time annotation from, by default, your tablet or phone camera or from your sensor itself. To finish that annotation, I press confirm, and I'll call it switch 3. Then you use the arrows on the left and the right to add any details to your particular annotation. Test details, and then press OK and complete when you're happy with that. If you want to add more annotations, you always have the ability to add them manually, and this will be a great way to highlight the custom annotation class that we made earlier. So if I wanted to also annotate to this other switch over here, I can do add. And then instead of just our default point, plane, or cylinder annotation, I can select more and select our webinar annotation. So this is the specific annotation class that we set up earlier. Call it switch 4. Any details again that you want to put in here. And you'll notice that it didn't ask for web length this time because that wasn't a required field for this custom annotation. And then press OK. So now we have 2 annotations as reflected on the top of the screen. The other major feature update that we have here in 4.0 is the multi-measurement capability. So if I go to my Measure tab and I select to measure distances, in past releases you could take a single measurement and move it around to get as many other calculations as necessary, but you couldn't save multiple measurements into your scene. So as soon as you press that Measure tab, you're immediately measuring, and you just press and hold or click and hold if you're on a mouse and keyboard. Use the zoom window on the right to select exactly where you want to measure to and from. If you didn't quite get it exactly as you want, it's very easy to adjust in our software. So you just press that green circle and then adjust until you're happy with exactly where you're measuring to and from. Now, if you want to create another measurement, it's really easy to do so now. So you can toggle your units down below and either press the plus button to add a measurement or the duplicate button to duplicate, which can sometimes be very convenient. For example, to get height and width of this panel, I can then duplicate and then just press and hold and drag, and I'm able to kind of build measurements on top of each other very easily. Or I can just more traditionally press the add button, select a corner, and release. And all 4 of those measurements will now save directly into the DP file. If I need to fix this, because I accidentally selected the ceiling, you can just move those circles around. As far as other additional features that we should touch base on here, we also have the April tag display. So if I go to View April Tags, this pulls up every April tag that's recognized in my scene and tells you the unique April tag ID. This is a great opportunity to point out that you should never, ever have 2 of the same April tag in a scene, because what they're doing behind the scenes is recognizing the unique center point of each tag and making sure that they're very accurately aligned within your scan. In this case, we didn't do so because it was not the priority of this particular webinar, but we do have measurements of this room between these April tags. So if I wanted the absolute most accurate data of this scan, I can tell Dot3D what the distance is between 143 and 133, and what the distance is between 137 and 184. And that's what's called scale bar targeting. It's a great, convenient workflow to really get highly accurate results in your scan with just a few additional measurements. Even without those measurements, the April tags are still helpful for accuracy automatically, as long as you loop over them multiple times while scanning. So once we're happy with our cropping, our annotation, our measurement, and we're ready to move forward with our scan, we go to File, Save As. And we'll indicate that this is the appended optimized version. So I'll call it AO. Oops. AO. Press Done. Every time you save or export from Dot3D, it'll ask you what your output transform is. In this case, it's auto-selected user defined, which is what we'll work with. If you had control targets, so known target coordinates, that is an option. If you had a design CAD file you reference to, that would be an option. Otherwise, you typically will use user defined or automatically detected. We'll press Save Scene. And with that, we will switch over to the questions that have come through so far and address as many of those as possible. We're already running over on time, but we will get to as many as we can and then gladly follow up with each one of you via email this week or next.
So we have a question here is, what is the cause of the limitation in scanning size, and will bigger scans be possible in the future? I think I'll let you take that one, Rafael.
Yeah, absolutely. So the cause is simply that today we cannot hold so large scenes in RAM. So and it's actually different on Android versus Windows. So and also I have to say in the later Android versions, in the Android 9 and Android 10, especially on some of those newer devices, ironically, even though they have a lot of RAM, they have 4, 6, or even 8 gigabytes of RAM. I think some even have 12 gigabytes. Android seems to set a limit, or rather, the graphics driver seems to set a limit in terms of how much memory can be allocated for an app, and it seems to be somewhere around a gigabyte or 1.2 gigabytes. And past that, it just wouldn't allow us to allocate more memory for the scene. So at that point, it would throw us out. That is a bit of an unfortunate limitation today. On Windows, it is less severe. On Windows, graphics drivers are better quality, and you don't get that sort of limitation. So if you have a machine with a decent amount of RAM, let's say 4 gigabyte, 8 gigabyte, 16, then you can scan decent sized scenes. So having said that, that is basically the current architecture, what we're working on. I cannot give you a release date for that, but we're really actively working on that as we speak, is a new design of the core engine that would basically allow you to scan really large scenes, like probably 4x, 5x, even 10x of what you have today. There are going to be some longer optimization times, even though we're trying to, or we are going to heavily optimize that as well. But it is definitely possible in the future to do much larger scans. Let's say you want to scan your house, you can walk around your entire house and scan that. Or you have a large apartment, you can scan that in one go. That has been one of the major requests of customers, and we're really trying to address that.
Awesome. Next question, kind of similar, is, will it be possible to stitch scans together without a third-party software like Recap? So I can touch base on that quickly. So the answer is yes, already today, using April tags. So that's one. There's multiple options, including third-party software, but one convenient option you have is to, if you're not using the append feature like I just did, you can do it more accurately even using targets. So if you export the target April tag IDs from one scan, you can import them into another scan and perform a target-to-target registration within Dot3D. I believe we will also be improving the options for that within our own environment in the future, but in some ways it's already there. Next one, yep. Rafael, is
or did you want me to add more to the stitching?
It's okay. We've got a lot of questions here, so we'll try and
Sure.
get through at least a few more of them before we close out,
Yep.
and then we'll reach out via email. So are there plans for online visualization of the scans?
Yes, there are.
I knew the answer to that one, but I thought you might want to say it yourself. So that's in the works.
Yep.
Please stay tuned on that front. Next question here is, are there plans for an iOS app? Similar answer.
That's right.
So please stay tuned. It's an active development. We envision that, as we went through earlier today in the presentation, each different camera is going to have its own pluses and minuses, but we expect to see some nice pluses and minuses with that option as well, including the fact that it's going to be already is built into tablets and phones.
Yeah, also the fact that we plan that you will be able to combine the best camera for each job, right? So as we said earlier, some cameras are good in one scenario and not so good in others. And the same is true for the iPad or the iPhone. And so if you scan something and then you encounter a particular spot where you would get better results with a different sensor, you just continue with a different sensor.
Definitely. So this question, from my experience, D455 is much easier to handle than the L515. Do you have any recommendations on which to use when? I think we maybe covered a decent amount of that later in the presentation. But in short, D455 is going to be your better option for exclusively outdoor sunny scanning, combination of indoor and outdoor if you only have one camera at your disposal. L515 is going to be a more accurate option for fully indoor environments or scanning in the dark. So you can utilize the L515 outdoors in the dark. So next question here. Will we provide a PDF or a PowerPoint copy of the presentation? Absolutely. So we'll not only provide a copy of the presentation, but we will provide a full recording of the webinar, cleaned up to save any of the holdups that we unfortunately experienced with the Wi-Fi connection today. And that'll all be sent out by the end of the week, if not tomorrow. For closer indoor scanning, say 1 foot to 5 feet, is the D45 or the L515 better? If it's fully indoors, I would definitely say, unless you're dealing with a lot of dark black shiny objects, the L515 is going to be your better bet. For that level of close range scanning, 1 to 5 feet, I would also recommend considering the DPI-10 SR, the PrimeSense based camera, which is still our best option for close range scanning. So getting as close as possible and getting as much detail, for example, on particular pieces of equipment. Next question, is the new software version a free of charge update if I use Dot3D already? In most cases, yes. So if you're a current subscriber to Dot3D Pro or Dot3D Scan or any version of Dot3D, the update is free of charge. If you are a perpetual license holder, so for example, a DPI owner, you do need to have your maintenance up to date in order to take advantage of these updates. Just contact us if you are unsure of that, or you can always try the update and see if it allows you. But if you haven't updated your maintenance on a perpetual license, that will be required. Some feedback on your comments, Rafael says UTM coordinates would be great, so noted. Next question is, can you scan a small object? Yes and no. While we have this wide range of cameras we now support, depends on how small an object we're talking about. But our currently supported hardware options are best suited for room scale or larger equipment scale scanning. Again, the DPI-10 SR would be the best option for smaller objects, but nothing too small is going to be a fit for us currently. Obviously, as we mentioned a couple times during this presentation, our goal is to continue to support different cameras for different situations. So we may add a even more close range discrete detail camera in the future. So just stay tuned on that front. Next question, could we have access to the point cloud you just created? Definitely. So PowerPoint, video, point cloud, we will get all that to you by the end of the week. How big was the scan file in size? Let me take a look and I'll give you the exact number. 38 megabytes. So that was actually both scans combined into one, still only 38 megabytes. So each of those scans individually is probably so small you could even attach it to an email. This is a very nice benefit of our own compressed point cloud format .dp. Next question we have, how can we try your product in version 4? So if you already own a RealSense camera and you want to try out Dot3D, I'll just direct you to dotproduct3d.com/dot3d download. That's where you can download the latest version at any point in time for Android or Windows. And also from dotproduct3d.com, you'll need to subscribe or sign up for a free 14-day trial. We saw in the surfboard use case, they got a 1.6 millimeter accuracy. If I use my D455, I already have, will I get a similar accuracy? So especially if we're talking about object or equipment type scanning like that, you're not going to be able to achieve quite that level with the D455. That was with the DPI SR model, which is still available. And that's what we would recommend for those type of situations. You know, you can get the accuracy close to the 2 to 5 millimeter level if you reference some known measurements to really inform your scale, but the level of detail isn't quite there with the 455. So again, each one has a different benefit. So last question here is what is the expected output resolution for the scene scanned? This is somewhat dependent on the user and the level of detail that is captured. This is part of what you're seeing in that green and yellow feedback while scanning. So if you get an area nice dark and green from a close range, you're going to get the highest resolution data. That isn't the only component that's being taken into account in the green and yellow. It's also time on target, distance, reflectivity, so an overall feedback report on your quality. But if you turn an area nice and green, you can expect a resolution of 1 to 2 millimeters, especially if you've looped over it and painted it nicely. So there's a few more questions here, all excellent questions. So very excited by the level of participation in today's webinar. And thank you all for joining us on the line today. Thank you very much, Rafael, for your contributions from Germany. And we will follow up with everybody who asked a question individually, and we will follow up with every single one of you with everything that we just talked about. So the recording, the data set, as well as the slide deck from today. And we look forward to connecting with you and answering any more questions that you have. So thanks again, and enjoy the rest of your day.